So we said 2 lectures ago that we needed to have the degree of the numerator one more than the degree of the denominator. That's true here. So we know that we will have an oblique asymptote. We're going to need to use long division. Do you remember how to set that up? Why don't you pause and give it a try? So you should remember that you need all descending powers of x, and there were no x squareds or x to the power of 1. So we use 0 as our placeholder, and then we divided first terms. X cubed divided by x squared is x. We multiply our quotient by the divisor. And then we subtract all of this. We should always have 0 in that first column. Minus 2x squared plus 3x, bring down the next term. Again, we're dividing first terms. So we have negative 2x squared divided by x squared gives us minus 2. We can actually stop here. Remember that all we're doing is looking for that equation in the form y equals mx plus b. We don't need the remainder. So we found our oblique asymptote, y equals x minus 2. Here's one more. Why don't you do the division and find the oblique asymptote? This one was a little tricky. You had to make sure you had all of your descending powers of x. So I noticed in my divisor that we were missing x to the power of 1. And in the numerator, we are missing x cubed, x to the power of 1, and x to the power of 0. People often forget that last term. So now we're dividing first terms, x cubed, or sorry, 3x to the power of 4 divided by x cubed is 3x. And always be careful when you're subtracting. That's the place most people make a mistake. And now we see that we're going to be dividing by 3x cubed divided by x cubed is positive 3. There we have our oblique asymptote. We don't need to go any further, although you might want to if you just need practice doing your division. In the next lecture, we'll look at putting this all together and finding all of the asymptotes for a function.